So I hope the slides are visible to you. Right. Is my presentation visible?
Yes, sir.
Yes,
Okay.
sir.
Okay, fine. Thank you. So basically, this is not only going to talk about vehicle to grid. Initially, I thought of only talking about vehicle to grid because that's also very challenging. But I mean, some more promising options that we have available along with vehicle to X, where this X is to be replaced by anything that you can think of, like vehicle to vehicle, vehicle to home, vehicle to load, vehicle to grid, right? And so that's why I say it is a promising option for electrical vehicle sustainability. Today, though we have been talking about electrical vehicles, we see a large market in front of us, but yes, still very few takers. So what is the basic reason behind it is also one of the part of the talk, right? So and since I have also been working on a DST based project, which is actually talking about vehicle to grid and then energy management aspect, so I am also going to touch upon this, right? So if you permit, this is an session where it's not one way. I mean, I'm not delivering any lecture to students. So all of you are faculty members. So it's, I mean, whenever you wish, you can always ask questions. Please don't hesitate. In fact, that will also, I mean, give a better understanding, right? So this is what the present scenario of power system is. So how this actually the talk scheduled. So we are going to talk about what exists today and where we are heading to, right? So in that heading to, so there are multiple dimensions which we can go into, but we are going to choose one, which is vehicle, and then vehicle to X, right? So today we all understand that existing power system is under immense pressure. I'm sorry if there is some disturbance. You just wait, I'll ask them to. So these all are the challenges which we have. Just a minute, I'll get back. Yeah, I'm sorry. So if you see the current power system scenario, so the current power system scenario, I mean, this definitely is under immense pressure to meet increasing energy demand. So energy demand is not the earlier we had. The energy demand is coming from different type of loads. The major challenge is also not only about catering energy demand, but also to maintain power quality. The customers is actually all the customers are expecting a good quality of power. So that is another challenge which is there on the existing power system, right? As we are aware that different type of nonlinear loads are increasing and day by day getting into the system, which are posing different challenges on power system. So that is also another aspect of it where a lot of people are working and a few more I mean, a lot of people are working and some good results have come out. So handling a nonlinear load along with linear loads is really a challenge. apart from generation, I mean, from generation point of view, if you see, the prime objective of power generation system is that it has to be economical, as you see here, it has to be reliable and good quality power supply. The moment I say economical, we think of renewable sources of energy. When I say renewable sources of energy, why it's very economical, you will get everything for free. But since you do not have the certainty of power availability from renewable sources of energy, we will not be able to rely on them 100%. So absolutely today, if you see, it's almost impossible that we fully get rid of fossil fuel based power plants. We have to have them here for, I mean, all the time that you see in future, right? So we can, yes, obviously efforts are being made to reduce overall burden on the fossil fuel based power plant, but yes, we cannot 100% reduce it, right? So the non-conventional sources of energy, though we get energy very economically, but this is one challenge. Same thing, though they are economical, but non-conventional source of energy also not reliable, right? So since they are not reliable, other challenge that is also posed by them is good quality of power supply. You have solar, so you understand how many conversion stages there, right? So since you have multiple power electronic interfaces in between, we don't finally end up with a good quality of power supply. So what happened in this power system when after 2003 Electricity Act was passed in Parliament, restructuring was done. So the conventional power system that we had earlier, in fact, before 2010 or 2015 in some of the states, now more or less it has been restructured, and we have different generation companies, we have different transmission companies, we have distribution companies. When all the three different entities were given responsibility, now they became more responsible in the sense of earning or making profit. So since they have to earn, earlier, since it was all vertical integrated utility being managed by State Electricity Board, it was very difficult because it was very difficult to fix the responsibility of the loss. Now, since you have different entities, you have you have generation companies, you have transmission companies, and you have distribution companies. So now you can fix the responsibilities. Okay, so generation also has to make profit to not only to pay salary, but yes, to enhance their own infrastructure or own facilities. So they have to make ultimately money. So they also became very responsible. Transmission companies are there. They are also pushing themselves into new advancements, particularly say in terms of ultra high voltage transmission line, or it is extra high voltage transmission line, or HVDC transmission. So a lot of efforts being made at that end also. Similarly, distribution companies, which we will actually be taking and talking about all this distribution aspect and challenges of electrical mobility, right? And that V2X option. So distribution companies, so each state has multiple different distribution companies. Distribution companies were actually the most affected due to this VIU, right? So distribution part, not distribution company, but yes, distribution part was the most affected. So a lot of revolutionary change have been brought in after that act, and since distribution company are independently handling a particular part of the state, they have imposed a lot of new rules, new regulations, new technologies in order to enhance the quality, because ultimately a customer getting power from distribution company. So I'm going to make complaint to distribution company. So distribution company is now free. They can directly, if you see the diagram, which is quite evident here, you can see generation companies are, distribution companies, distribution company can directly buy power from generation company. They need not to have the earlier system, right? So if a generation company which is outside the state. Distribution company, I mean, so a lot of competition has been brought in after this. So distribution companies are free to buy power, right? Either they go with this channel of their own state, transmission company and distribution company. Otherwise, distribution generation company can directly get power from distribution company get power from generation company directly. So that has brought competition. So that brought competition to the generation companies as well, because they wanted to sell their power to distribution company at the cheapest rate. So whoever is giving distribution company the power at the cheapest rate, that will be opted for. So all the sectors were under heavy competition, and now more or less the things have been streamlined, at least this as far as this part is concerned. Still, there is an independent system operator which is actually managing generation companies, your transmission companies, and distribution companies. So it is under control of a body which is being managed by government. So now, when you said this is a conventional system, and we are making the system smarter in terms of load, smarter in terms of generation, smarter in terms of distribution, right? So this whole concept got changed, and now people say it has become a smart grid. So what is that, a smart grid? Instead of smart loads, you'll have a smart generation. You have to think of smart management that you have to think of. So what is that smart management? What is that smart load? So to understand that, we should understand what is the basic difference, the difference between the conventional grid and the smart grid. So it is quite clear from the two. We ultimately same. I mean, I still have to get the tube light on. I have to run that fan. I'm still getting the same. You also used to listen to the voice on this phone, and now also in the smartphone. But what advantage the smartphone has given you? It has given you more flexibility. You have multiple applications to it. You can do multiple things here. So broadly, if you see the smart grid architecture, a lot of changes happening on the generation side, transmission side, and distribution side. So when I talk about, I will not go into detail of generation and transmission, because our focus will be mainly on the distribution side and the different type of loads and what are the challenges we are actually facing, right? So generation, as I said, the smartness has been brought in generation by introducing non-conventional sources of energy. Earlier, if you you remember, the generation capacity of a single windmill was, if to a higher side, if you see, it used to be 3.5, 4 or 4.5 megawatt, one single unit. Now, when I was just reading almost a month back, in Germany, they have come up with a windmill, single windmill, which is capable to produce 15 megawatt of power, right? So 15 megawatt of power, one single windmill. If you have multiple, wind farm of such windmills, you can have almost electricity for free in time to come, probably. But the challenge that I see is suddenly wind gust, all windmills will stop. So who is going to supply power during that time? So because it is not controllable, you have a lot of challenges, right? Similarly, is with solar farms. You have seen in our country where we have large, huge solar farms, even one solar PV having capacity approximately of 700 megawatt, right? So that's the magnitude which we are currently working on, right? And so this is the part by which, this is the portion, these are the different ways by which we have brought smartness in the generation side. So the transmission side, if you talk about, you have grid automation, you have smart switches, we have SF6 substations, right? earlier, when I think of substation, the long, huge mesh of wires here and there, and occupies a large space in the large space of the land. But now, when you have such a compact, intelligent substation, it has almost reduced to one tenth of it. I understand the cost, which is a major issue here, but what we are talking about is futuristic. All these things are going to happen, and we have started seeing these things in our country. So, intelligent substation, SF6 type of substation, where we have almost reduced to one tenth of the size, you can assume how compact it has become, how smart it has become in terms of overall monitoring and control, right? So, and the third and most important part where we have seen maximum change is on the distribution side. Distribution, the maximum changes, challenges, why we have seen, because it is directly linked with the customer. When I say it is directly linked with customer, so you and me, if we see, earlier we had that conventional bulbs in our houses, right? It was just tube light, and you had fans, right? Mostly you had linear loads. Today, when you see the load of your own house, you see so many electronic gadgets. So all of them have semiconductor devices in it. They are bound to be non-linear loads, right? So in our household, if I see, we have increased overall non-linearity in the load, right? So how do I handle all of this in the with the assurance of giving customer a cleaner power, a quality power, right? So if you see, there are two important aspects which have been researched, and also a lot of fund is being issued or released in storage aspect. So storage aspect, if you see, storage of energy. Storage of energy is really a major challenge. When I say storage, you do not have today also, if you see storage, I say you have 600 megawatt of or 700 megawatt of solar plant, right? If you have cloud on it, gets reduced to say 100 megawatt, or sometimes it may, even if you take in the night time, you don't have even a single watt coming out of it. So unless you give a solution of energy storage, this is really difficult to give assurance of 100% reliability on renewables, right? If you have energy storage associated with it, yes, you can bring this reliability in the overall grid system, right? But I mean, we cannot think of such a large 100 megawatts of storage. We cannot think of a 1000 megawatt of storage. I mean, that's almost first storage plant, as some of you may be aware of, which is started by Tata in Delhi. That's 10 megawatt storage plant. So 10 megawatt energy storage plant that's being built up there in Delhi. I think it is also functional now. So efforts are being made in this direction also. But yes, it is not very economical. Even today, though you have huge battery banks available, but still it is another. It's not only economical, but its safety aspect is also one major issue when you see a huge, large lithium-ion batteries pack kept at one side, right? So a lot of research also being done in energy storage side. So this is one major challenge that we have. Another, if you see Indian scenario, By the government has said by 2030 we will not have we will not permit any gasoline, I mean petrol diesel based vehicles, and most of the vehicles will be electrical vehicles, right? So this is what they are aiming at. Most of the countries have announced this, that in time to come, probably 10 years down the line, they will not have this petrol or diesel based vehicles, right? On the same lines, India also has announced and working in this direction. So when I say electrical vehicle, so electrical vehicle, when you say it looks fine, okay, yes, you have to get it charged, and that's it. So today, if all the vehicles are replaced by electrical vehicle, we don't have power even to charge them, right? Even overall, if you see the total statistics, if all vehicles are replaced by electrical vehicle today, you don't have that generation of power generation available, right? So how can you imagine that? Correct. So there has to be a solution to it. So solution to it is, before we go to that solution, I mean, solution is hidden in this block itself, where we are going to talk about smaller aspect, right? Why, when the moment I see a larger grid, I always see a large challenge. I mean, challenge in terms of generation. When I say grid, in terms of megawatt, gigawatt, storage also. If I think of grid level storage, it will always be very huge in imagination, which is practically almost impossible. So what is also being planned, and if you see some of the cities which are now restructuring all this, and in fact government of India also promoting a smaller grid. Take example of your own college campus. If that campus helps you in, if there's a campus, not only campus, but overall infrastructure is planned in such a way. Infrastructure means your overall civil construction of the building, and mainly electrical generation is designed in such a way that you generate your own electricity and meet your own load. That's only possible because you say we have solar power plant that generates, say, 60-70% of the total power, 30% is bought from the grid, and then you manage, right? You can also have, I mean, these are the options which are coming up. This is a smaller grid. So if I take my own institute building or institute campus of 350 acres, this becomes a microgrid because we have sufficient solar to meet our demand, correct? And so since demand is met from the generation, which is almost free of cost, but still I will have to have this grid interconnection or point of common coupling with the main line always ready. Reason? Because this is not very reliable. So because it's depending on the weather, right? So today, when I say this campus becomes a smaller grid, so that it is named as microgrid. It is a microgrid, fine, microgrid, but I mean, how is it different? Difference is we are given incentive because we are producing our own power, right? It is easily manageable because it's a microgrid. You have manageable load, you have manageable generation, and you have all of them easily controllable. Correct? This becomes strengthened, and definitely as we see technology progressing, we will also have soon good and storage option. So if I produce sufficient power and also get energy stored for rest of the time when you don't have power from solar, I mean, this becomes independent. But this is also practically not possible because load is also increasing and storage is of equal amount is not very much economical at this stage. The option that we see here is this wind. So what is that it doing? So I don't have to. Pilani is a small town where you don't have wind blowing all the years, all the time. Even don't have any hill area where you can place a windmill and get a line connected. So since it has become competitive, as I was talking about, you can have your windmills in Jaisalmer where you have wind all through the year. Get 2 windmills installed there. Those windmills are going to feed power to the grid, and power can be bought or can be used here in Pilani. So this is one way. Yes, you will have some transmission charges which are nominal. You have to ultimately pay and get the power at your end, right? But what will happen if all these things are fine, but as I said, new challenges which are coming in. When I talk about electric mobility, you will have electrical vehicles. Today we have approximately 250 cars in the campus. Right? If all the cars suddenly become electrical vehicle, I'm just taking a smaller number to understand the magnitude of the problem. All these 250 vehicles, if suddenly become electrical vehicle, each electric car will have approximately 20 kilowatt hour of energy. I mean, that's the capacity of the range. Though it varies from say 15 to 45, and higher vehicles it increases. But on an average, if you take say 20, even 20 kilowatt, so that is the requirement. Into 250, we don't have that much of power, right? Though even if you require just 10% of it, 20% of it, even that power is also not there, right? So then how do you imagine it is getting implemented in the country? So this is one of the major challenge in terms of charging, right? So this electric mobility will only be economical, will only be sustainable when we have surplus power from renewable sources of energy, charging station being fueled by renewable energy, and catering to this electrical vehicle charge. Dedicated charging only from, not from the conventional, but from the, and you also have to have storage in it. So when you see this is happening, you have to, so and the others are the linear, non-linear kind of loads. So all of them have to be controllable. So this is basically a microgrid structure where major challenge that we are currently working on is electrical vehicle. How best we can utilize the energy storage capacity of the vehicle, right? So just to sum up this, you have microgrid which will get connected to other microgrids around it, but is very much depending on weather forecast. We still don't have very strong forecasting mechanism who can say, yes, tomorrow you have solar irradiance from this time to this time, this much, from this time to this time. A fixed amount, the firm amount of the firm value is told. No, it's not possible today. So unless you have weather forecast mechanism well established, well structured, all these uncertainties will remain there, and we will have to think of a larger storage option, right? And then yes, you have advantage of microgrid. If you have surplus power, you can sell that power to other grids, you can sell it power to the main grid, right? So how do I see electrical vehicle a promising solution? I see electrical vehicle a promising solution because you obviously you reduce fossil fuel consumption, greenhouse gases emission is reduced. Uh, it can reduce high cost of regulation and spinning reserve. If you have read in recently, a lot of money goes waste. Actually, a lot of money is going waste only maintaining these spinning reserves, right? And these are the plants which are run at its capacity when the peak of the load comes, right? So obviously, if you have electrical vehicle, these things can be brought down. So how will it be bringing it down? Is this. When the government tabled the first white paper on electrical vehicle a few years back, they also had this in mind and mentioned that user should have option to sell electrical power that it has is stored in it, right? So so that was the option which is generally known as vehicle to grid, where you can supply electrical power back to grid and grid gets that additional power. But if vehicle getting charged from the same conventional power and giving it back, we do not see any profit in it, right? So this is the initial part of or the introduction of vehicle to grid. I mean, all these terms that you see around us, like decarbonization, you have energy efficiency, all these things also come along with electrical vehicle, is the reason electrical vehicles are being promoted. Another part of electrical vehicle promotion is not only bringing cleaner power to it, but dependence on those countries. I mean, we are heavily depending on various countries on oil, right? Since we buy oil from them, we have to pay huge amount of money. So, and most of the fuel is used in driving vehicles. So that is another way to look at it. But yes, if you only talk about electrical aspect, we have vehicle to grid here. So can we take some questions if you wish, or I'll finish discussion and then we'll have I mean, how do you suggest?
Sir, please finish your discussion.
Okay, first I'll finish my talk and then we'll have discussion. Yes.
We'll have
okay.
Question session.
Fine. So this is integrated. So integrated model of vehicle to grid to supply instant power. It's not only, it's one of the factors is just to regulate frequency, but it is not only one vehicle who can actually regulate a grid frequency. Correct. So here, when I talk about grid, it is not a larger grid. I'm talking about a smaller or micro grid, right? Where this is very much feasible is the reason I introduced a microgrid scenario to you. So this vehicle to grid is actually, you can see this two-way arrow because you have control. You can sell power. You can also anyway, you have to buy power to charge the vehicle. So what are the multiple or different energy storage technologies available? Different energy storage technologies which are there You have chemical storage, you have thermal storage, electrical, electrochemical, and mechanical energy storage, right? So, but when it comes to vehicle, you have very few options available. Yes, it is only electrochemical batteries which we can think of right now, right? And when we talk about a larger storage plant, we have yes, ultra capacitor, super capacitor. We have superconducting magnetic energy storage, SMES, uh, as options. But they, so ultra capacitor in vehicle is one possibility of storing charge, storing energy, uh, and electrochemical are the other solutions, right? So, I mean, how serious the government is about National Energy Storage Mission? They have, if you see here, this is the part which is one of their uh, prime objective, right? Developing a storage component of electric mobility plans. So this is what they, when I say we don't have sufficient power in the sense we do not have, today if you see the total installed capacity is very large, but when I say all the electrical vehicles are transformed, all the vehicles are transformed into electrical vehicle, we don't have that amount of power available, right? So developing a storage component, so why can't we make such a mechanism where storage of electrical vehicle is used in multiple dimensions, right? So electrical vehicle, if you say it's a source, right? We all know it's a load. Yes, you have to ultimately get it charged, but we have to see the other option so that it becomes more viable, right, or sustainable, right? Today, if you see, the cost of the battery is approximately 30% of the cost of the vehicle, and you know it has to be replaced after 4 years or 5 years. So you are going to invest in 30%. So these are the other challenges which are actually restricting a user or a customer to go for electrical vehicle. Anyway, so electrical vehicle as a source, if you see from the other side of it, so you have multiple options. What is that? First is you can have vehicle to vehicle. So vehicle can transfer electrical power to another vehicle, right? Uh, Similarly, vehicle to home, you can transfer power from vehicle to home, right? So if that works fine, vehicle to home. If your car is parked in the in your house, you don't have to buy an inverter, right? Power goes off, you have vehicle, it can cater to. I mean, the amount of battery that vehicle has is much more than the battery of the. I'm talking about the capacity, energy storage capacity of the battery is much more than the uh, batteries that we use in the inverter. And when you talk about vehicle to load, you have, I mean, it is similar to vehicle to home, but a place where you urgently need power, it can actually cater to. And then finally, it is vehicle to grid. So it is actually, as I just said, that vehicle to grid looks pretty difficult to achieve. But yes, vehicle to microgrid is possible, right? And that is what we have been doing. So what are the advantages that you see of vehicle to grid, right? So vehicle to grid, or in another way, it is vehicle to X advantages, right? So the advantages that you see of vehicle to grid is you have this vehicle, it is fully charged, and you are supplying, though it is getting charged here, but you have other arrow also in the same direction. So apart from generating revenues and reducing peak power demand, it also helps us in enhancing grid stability. So here when I say it is single electrical vehicle, no, it is not single electrical vehicle, it's a fleet of electrical vehicle which is parked. Take example of a mall. Just take example of a mall and the basement where you have 1000 cars parked, and since all of them are electrical vehicle, and if they agree to discharge say 50% of their power, the whole a substantial part of the mall can be powered, right? So that is one way which we can think of, right? So if I get my vehicle charged from a solar rooftop which is there at my home, I almost getting it charged for free, right? And then I go to market, I park my vehicle in the mall and sell the power, right? Commercial rates are slightly higher. You get that power sold and make money out of it. Not money, but some sort of incentive, because you are providing or you are supporting grid by providing your share. So you will get some sort of incentive. As you are aware that incentive to buy electrical vehicles, you have recently got 1.5 lakh rupees of subsidy, and you have different number plate, so relaxation and subsidy there on the national highways. So efforts are being made from the other direction also to pump in this buying of electrical vehicle. So I was talking about it. So it's not one vehicle you can say it can handle grid stability and it can think of reliability. No, but it's a fleet of vehicle and all of them getting stored at a particular place, and then you have and then you have supplying it to other part of it. So this is one. You have obviously this is also getting solved, better integration of renewable sources, because you have vehicle itself storing power, right? Another is vehicle to load. So this is another advantage of vehicle to load. So apart from all that you have self. It can be consumed as self, because I said you will not have to buy an inverter if you have it, right? So it used as a generator when you have outages, provides power at remote sites. Higher independence is fine at emergency situation. This can also help. So when you have all these advantages and when you think of getting incentive out of these advantages, probably can push you and me to go for electrical vehicles, right? So vehicle to home is another option which is more or less similar to vehicle to load, but vehicle to vehicle is also advantages that you see. It's helping either your own vehicle or your supplying power to some other vehicle, right? Efficient electrical vehicle parking management is also one which you will have when it is vehicle to vehicle. So you will get advantages of it. But yes, all these are acceptable barriers which we are aware of. So you have market and regulation. So market and regulation, you still do not have any policy. But yes, there are a few developed countries, but very smaller, like you talk about Denmark, a small country where you have already regulation in place, you have market in place, you have infrastructure in place. These things are happening. But if you see the country with a magnitude uh, of such large magnitude, it is really difficult to make this happen in very recent time, if you see 1 or 2 years. But yes, if you see a longer a perspective, say 10 years or 15 years down the line, probably this would be there. Still, we do not have any rules, we don't have any market regulations for it. But yes, probably when, since a lot of new policies are being framed with respect to electrical vehicle, these things are also being stressed, right? And will be seen by us soon. But yes, implementation, as I said, will take a long time. So rules and business processes must be clear, limited coordination between stakeholders. As of now, you have a battery getting degraded. What will I do with those batteries? Can you think, okay, I buy electrical vehicle, right? 1 lakh electrical vehicles. You'll have 1 lakh such large, huge, big batteries stocked in the yard, which is also not, which can not simply be disposed of. Right? So how will that be implemented? So there has to be a policy on that before we actually push for electrical vehicles, because consequences of this would be hazardous and very dangerous if we don't think of it now, right? So technological development also, if you see, no vehicle, you will see every vehicle has a charging point at different places, right? You don't have any standardized protocol in it, right? So since there is no standardization done so far in the technological aspect, this is again posing a challenge, right? So non-uniformity, and then this if you say no EV full charge availability guaranteed, like you have how will that ultimately be paid? Users engagement is what I mean. How do you see this? So if you see in technological development, electrical vehicle is fully charged, right? I see, as I have my mobile phone, you see 50% of battery, 20% of battery. So how will that be taken into account if I start selling power, right? How will that be taken into account? Because that is not a simple linear, okay, now it is 90%. When it comes to 60%, you still have 60%. But because it's a highly nonlinear curve of that SOC, you will have to have some fine-tuned and mechanism for it, correct? And for user, you don't have subsidies. Obviously, it is initially needed. Awareness of vehicle to X capabilities, that also has to be made. I mean, that has to be brought in along with the electrical vehicle promotion. So if all these things go along, and if some of these barriers are addressed, then we can think of good electrical vehicle. Another aspect on which we are working is uh, a battery swapping station, another option that we have been working on. Though it's not the pure electrical part, but yes, requires, and we have been working with faculty members from economics department on it, and some of them are from management. So what is that another research gap? So I have already told you and given you a broader idea of vehicle to grid. So one of the domains can be picked, and you can think of working on it. This is another aspect. If you see from the management point of view or from the economics point of view, when I say a lot of electrical vehicles on the road, we are still talking about the e-rickshaws, and you have two-wheelers or e-bikes, right? But still, when I see electrical vehicle, I think of electrical cars, electric buses, right? Public transport will be electrical. The trucks, they are transporting and which are consuming more fuel, should be electrical, right? So those vehicles, once they get converted into electric, then you can actually say you have electrical vehicle. But yes, if you see how many electrical vehicles, I mean, you have statistics right in front of you, right? So this is the fact which we are actually living with. Government is pushing electrical vehicle. Yeah, so many electrical vehicles, but what effectively electrical vehicle mean, which are really going to impact? Not seen. Also, the challenges here is about the same battery. Since it has just begun, we haven't seen the consequences of disposing of this battery, right? In the recent one of the accident that took place in Jaipur, because they simply pour that acid in the normal some household pipe. So later that caused a lot of damage, and very small, though it was very small, but yes, that could be more dangerous in future. So disposing of all batteries is really a challenge. So if you see, so this is one of the model, one of the business model one can think of. If some of you are if you are planning to think of some startup idea, this could be one. I mean, so there is no as such any business model or policy exists for battery swapping station, distribution company, and electrical vehicle owner. So what is swapping station that I'm talking about? And why is it not possible? Because of this non-uniformity, lack of standardization, right? All vehicles that you see are having different, all vehicles that you see are having different structure. They have different battery size, right? So this battery swapping is not possible as of now. But since we haven't gone far in this, still any firm policy can help us. That will help us also in reducing electrical vehicle price. So what is that battery swapping? I just tell you. If you have a vehicle, right? Just the way we change our gas cylinder, we go to that battery swapping station, park our vehicle, they remove our battery, replace it with a new one, and we move on. We don't have to buy electrical vehicles. So obviously 30% of the vehicle cost can come down. It's just like the gas cylinder in some of the cities. I mean, in our cities, we have to book a new gas cylinder. They take the old cylinder, gives us a new cylinder. They're not charging us for the cylinder, but yes, they are uh, charging only for the gas they have filled. Correct. So on the same lines, this is one of the options from where we can bring the cost of the electrical vehicle down. The battery swapping stations overcome some of the challenges that EV adoption is facing. It can also be worked as energy storage aggregator. So this is another term that we will have to use when I talk about vehicle to grid or vehicle to microgrid. A fleet of vehicle parked, I am discharging now, somebody else will come a little late, will discharge now. So where will ultimately, so there has to be an energy storage which can take power from all the vehicles, and it is nothing but energy storage facility which can directly talk to the microgrid controller level and supply the power. I will be paid according, or I will be given incentive according to the amount of power that I have sold, right? So this will go along with vehicle to grid. So it is energy storage aggregator with enough storage capacity to participate in electrical energy market. So in battery swapping stations, third party will have the ownership of the battery, so you have that advantage. Will be responsible for the replacement and swapping of the depleted batteries, so it is not customer's headache. That is anyway will be managed by them. Right. BSS owner will monitor the health and everything of the battery, and it's take care of decommissioning of the batteries after their lifetime. So this is a very good and challenging business aspect. So people are working from the technical aspects also into it by designing BSS, the type of batteries, and overall charging infrastructure for BSS. Right. So how will it work is explained through this animation. This is a battery sharing or swapping station where you have a lot of batteries placed in the folder, right? What will happen, and all these batteries will not be just one or two, there will be say hundreds of batteries. All these batteries are actually being charged from renewable sources of energy, right? But this station, now you see the business model, this station is there in the heart of, say, Pune city, right? This is the heart of in the heart of a city. So all these things are not possible. So these are located at far off place. Since you have restructured the whole power system, if you are consuming power, generating somewhere else, it's only transmission cost that you will have to bear, which is nominal, right? So this kind of model, a large business group can probably will implement. What will happen? They will have windmills in Tamil Nadu, windmills in Jaisalmer, power plant in also different parts of Rajasthan, but taking power in Maharashtra. Since everything is interconnected, it is very much possible, right? So taking power in Maharashtra, because it will not be one or two such stations, you will have hundreds and thousands of such stations, and amount of battery or the energy requirement will also be very, very large. So what will happen here? You have all the whole power, which is, so all the batteries which it has are getting charged almost for free or at very nominal charge. what will happen? So you have distributed energy resources, grid, and battery swapping stations. So DER is supplying either directly to grid, DER is supplying to BSS. So by both the routes, you can get power to BSS. Right. Now, if you see, so this is a vehicle which comes in. So this vehicle is giving the discharge batteries through a mobile applications. You pay the money. New batteries will, once the money is paid, new battery will come, will get there, get into the vehicle, and vehicle will move on. So this is the way which one of the ways by which we can promote electrical vehicles, because I don't have to buy battery, right? I don't have to buy battery. I don't have to think of maintaining it, getting it replaced ever. It's just vehicle. I'll keep moving on. Wherever I find, I'll take. So it's a win-win situation for both. Battery sharing station or swapping station will also be making money. Vehicle owner will also get an hassle-free drive, right? And anyway, this is going to be also going to give you power to the grid, which is a surplus power to the grid, and sudden requirement of power can also be fed to grid, right, whenever required, because you have such a large pool of battery stored here. It can be fed to grid in case of any requirement, right? So this is the reason we say, I mean, in time to come, probably it's going to be an earning member of your family. So so this is all the new aspects which are being researched in electric mobility domain. So it's not only control, protection, monitoring, but also a business aspect of it. Correct. So these are the things which have been done, and we are also working on many of them in our institute. So that's all I have as far as the talk is concerned. But I think since it is faculty development program, I think we should spend more time in discussing this. Is that fine? So now I think we should start our discussion.